So today we are going to start with the algebraic identities. Children, you have already done 4 algebraic identities in class 8th. So in today's class we are going to discuss the same 4 identities that we did in class 8th in little more detail. Now the first identity is a plus b whole square. As you all know what is a plus b whole square. It is a square plus 2ab plus b square. Now remember one thing, that a plus b whole square can also be written as a plus b into a plus b. Similarly, the second identity is a minus b whole square, which is a square minus 2ab plus b square. And a minus b whole square can also be written as a minus b into a minus b. Third identity is a plus b into a minus b, which is equal to a square minus b square. And the fourth identity is x plus a into x plus b is equal to x square plus a plus b into x plus ab. Now one thing you all can observe very easily here, that in all the 4 identities we are using the product of binomials. In the first identity we are taking 2 binomials exactly of the same type, that is a plus b into a plus b. We can also write it as a plus b whole square. Second identity is also as the product of 2 binomials, a minus b into a minus b, but because both the binomials are same, we can write it as a minus b whole square. The third identity is the product of 2 binomials, a plus b into a minus b, and the fourth identity is again the product of 2 binomials, that is x plus a into x plus b. But where is the difference in all the 4 identities? When all 4 of them are the product of 2 binomials, what is the difference? In the first case, we have 2 binomials with plus sign in between the 2 terms. In the second identity, we have a negative sign in between the 2 terms. In the third identity, and what is important in both the identities, that in both the brackets, the first and the second terms are also same. In the third identity, again, if you see, the terms are absolutely the same, a and b in both the brackets, but in the first bracket there is a plus sign, in the second bracket there is a minus sign. And the fourth identity is again the product of 2 binomials. Here there is a difference. The first term in both the brackets is the same, whereas the second term is different in both the brackets. Okay, and plus and minus sign can be anything. It can be replaced with a negative sign as well. So now let us see how to deal with these identities one by one. If I look at the first identity, a plus b whole square, I can write it as a square plus 2ab plus b square. Children, remember one thing, that this identity can be used in both the ways. Like for example, if I give you a plus b whole square and I say write down the expanded form for this. Expanded form. How will I write the expanded form of a plus b whole square? I will write a square plus 2ab plus b square. It means the RHS of this identity is actually the expanded form. Whereas on the other hand, suppose if I give you the identity as a square plus 2ab plus b square and I say factorize it, then you will say I can write this as a plus b whole square, and a plus b whole square is nothing but a plus b into a plus b. So isn't it the factorized form of the given expression? Yes. So that means this side is known as the factorized form and this is known as the expanded form. Let us take one example based on this identity a plus b whole square. Suppose I take x plus 5 whole square and I ask you to write the expanded form of this expression. What will you write? You will say that this matches exactly with the identity a plus b whole square. This is the identity a plus b whole square. There are 2 terms, here also there are 2 terms. So now I can say my x stands for a, 5 stands for b. So in this case, if I assume my a to be x and b to be 5. Keeping that identity in mind, what do we write here? A square. What is the meaning of a square? Means whatever first term is available, do the square of that. In this case, what is the first term available here? X. So we write x square plus second term is 2 into a into b. It means 2 multiplied by the first term multiplied by the second term. So here what will I write? 2 into x into 5. 2 into first term into second term plus b square. So what is b square? The second term square. So if I simplify this, I'll get x square plus 2 into 5 gives me 10. So 10x plus 5 square, which is 5 into 5, and that is 25. So what do we get here? That x plus 5 whole square, the expanded form will be x square plus 10x plus 25. Let's take one more example. Suppose I say I have 2y plus 7 whole square. Again, it is of the same format, a plus b whole square. I can assume this as a and this as b. Okay, but basically you have to remember the pattern. Pattern says a square. A square means that the square of the first term available. It is, in this case, the first term is 2y. So it is square of the first term, that is 2y whole square, plus we write 2 into the first term, that is 2y, into the second term, which is 7, plus b square, that is 7 square. So I will get here 2y whole square means the square is on both the numbers, that means 4y square plus 2 into 2, 4, 4 7s are 28, y plus 7 square, which gives me 49. In this case, children, remember one thing, when you write 2y plus 7 whole square, some of the children make this mistake that they write first term square as like 2y square, they write as 2y square, which is absolutely wrong, because the square is not only on y, it is on the entire term, that is 2y. So if you want to put square on the entire term, you have to write 2y whole square, then you can continue. So this is the main problem where you people make mistakes. So take care of this. Similarly, if I have an expression, say 3x plus 5y whole square, again I will consider this as my first term, this as my second term. So what is the criteria we follow? We first write down the square of the first term. First term is 3x whole square. I will not write 3x square. I will write 3x whole square plus second term is 2 into the first term, which is 3x, into the second term, which is 5y, plus 5y means the second term whole square. Again, you will not write here 5y square. That is absolutely wrong. It is 5y whole square. Now when I open the bracket of 3x whole square, it means square is on 3 as well as on x. So 3 square, I'll just explain you here. 3x whole square actually means it is 3 square into x square, which will give me 9 into x square. Now without the bracket, if I want to write, I will write it as 9x square plus 2 into 3, 6, 6 into 5 is 30, and then x into y. So 30xy plus 5y square. 5y whole square can be opened out as 5 square into y square, which will give you 25y square. Or another way of opening this can also be like 5y into 5y. 5y into 5y will give you 25y square. So I hope you all understand how to multiply these numbers. Similarly, if I want to use the second identity, there is just a difference of a negative sign in the second identity. Suppose I take the same example, 3x minus 5y whole square. What will I write? A square. Instead of plus, there is a minus sign. Rest everything is exactly the same in this identity that you have already done in class 8th as well. A square minus 2ab plus b square, which gives you 9x square minus 30xy plus 25y square. So it's very easy to expand these kind of identities now. Suppose I take one more example, say 3 by 2x minus 7z whole square. So whole square, and it is of the type a minus b. This entire term is a, this entire term can be considered as b. A minus b whole square. So again, first term is 3 by 2x and then put whole square minus 2 into the first term, which is 3 by 2x, into the second term, which is 7z, plus b whole square. Remember children, our a is 3 by 2x and b is 7z. Don't say that b is minus 7z, because we are using the identity for a minus b whole square. That means a will be 3 by 2x, b will be 7z. In place of minus, we have a minus sign here in the identity itself, which will take care of it on its own. You don't have to take minus along with 7z in this case. Now when you open out this, 3 by 2 whole square will be 9 by 4 and then x square minus. Now this 2 and this 2 will get cancelled. 3 into 7 will be 21xz plus here 7 into 7 is 49z square. So this is how we expand the identities a plus b whole square and a minus b whole square. Let's take the third identity. The third identity was a plus b into a minus b. As I told you, one is the factorized form, another is the expanded form. The factorized form will be the one where there is a product of two factors. So this is the factorized form and this is the expanded form. Now suppose if question is given as x square minus y square, I want to first take it in this form. Say x plus y into x minus y. I want to write it in the expanded form. It's exactly following the above pattern. So in both the brackets, the same numbers are there, x and y, x and y. The only difference is of the sign, plus and minus. So what is the expanded form? It's a square minus b square, means the square of the first term minus the square of the second term. So the answer will be x square minus y square. Suppose I say 2x plus 3y into 2x minus 3y. Again, this is my a and there is a plus sign and this is my b. Similarly here, this is your a and there is a minus sign and this is your b. Again, it is following the same pattern. A square minus b square we have to write. Now in this case our a is 2x. So if I write only 2x square, will it be fine? No, because I told you when I say a square means the first term entirely. There is a square on the first term. So 2x whole square. Similarly b square will be 3y whole square. Now 2x whole square would mean 2x into 2x, which is 4x square, and 3y square means 3y into 3y, which is 9y square. Similarly, I'll take one more example, say 2x square plus 3yz. There can be any complicated terms. You don't have to bother about those terms at all. You just have to concentrate on the identity used. जब आप देखो दोनों brackets में there are exactly the same terms. First term and the second term are same in both the brackets. The only difference is of the sign, plus and minus sign. So what we have to do? We have to use the identity a square minus b square. Now what is the identity? What is your a in this case? It is 2x square. This is your a. Now you say I have to use a square. It means whole bracket square. Then there is a minus sign and then b square. So what is your b in this case? 3yz, and then put a square on it. After that you just simplify. What is 2x square whole square? If you can't do it orally, write it in rough. 2x square into 2x square. How will you multiply them? 2 into 2 will give you 4 into x raised to the power 4. Why? Because we have done the laws of exponents. When there is a multiplication the bases are same, the exponents get added. Okay, or you can use the third law where the powers get multiplied. So the answer will be 4x to the power 4 minus 3yz whole square means 3yz into 3yz, which will give you 3 into 3 9, y into y is y square because both the powers are 1, they will be added and you will get y square. Similarly, power of z will be z square. So 9y square z square, or you can directly orally do it. Square on 3yz means the square is on all the 3 numbers. So 3 square will give you 9 and then y square and then z square. Same thing here, square 2 square and x square whole square. 2 square will give you 4 and x square whole square will give you x to the power 4. And this is the expanded form of the given expression. Now let's take the fourth identity. X plus a into x plus b will give you x square plus a plus b into x plus ab. Now in this identity and in this identity, can you see the difference? Here first and second terms both were same in both the brackets, the only difference was of plus and minus sign. In this identity, only the first term is same in both the brackets, but the second term is different. And this need not be a plus sign always, it can be negative as well. So now I would like to take one example of this type. Suppose I take 2x plus 5 into 2x plus 3. Can you relate this expression with the given expression x plus a into x plus b? Basically, we have to see that the first term, one of the terms should be same in both the brackets. 2x and 2x is same. The second term is different. So this is in place of x and this is in place of a and this is in place of b. Okay. So what is the expanded form? Expanded form is this form, x square. X square means whichever term is common in both the brackets, we do the square of that term. Here in this case 2x is common, so I'll write 2x whole square. Okay, again I am reminding, don't write 2x square, it is 2x whole square plus second term is a plus b into x. A plus b, here a and b are 5 and 3, so I will write 5 plus 3 into x. Here in the identity it is written x because x is common in both the brackets. But here in our question, what is common? 2x. So in place of x, I will be writing 2x plus a into b, that is 5 into 3. If you have written the first statement carefully, the second statement will be very easy for you to write. Just the simplified form of this statement, 2x square whole square will be 4x square plus. Now 5 plus 3 will give you 8. 8 into 2x. 8 into 2 will be 16x. Plus 5 into 3 is 15. This is the answer by using the identity x plus a into x plus b. Now let us take the same question. I am just writing in a different form. I can write it as 5 plus 2x into 3 plus 2x, or I can even write it as 5 plus 2x into 2x plus 3. So you just need to observe one thing, that we apply the identity x plus a into x plus b whenever in both the brackets one term is same. So you just have to, just don't bother about the position of that term because that can always be interchanged in the bracket. Here this term is same. If you want, you can write it as 2x plus 5 into 2x plus 3 just to match it with the identity x plus a into x plus b. Similarly, this expression 2x is again same in both the brackets. Just rewrite it as 2x plus 5 into 2x plus 3 to match it with the given identity x plus a into x plus b. Now let's take one example where one term is negative. Suppose I take as 2x square plus 5 and 2x square minus 3. Okay, you don't have to bother about plus and minus signs in this identity x plus a into x plus b. Plus and minus doesn't play any role here. what is important is that one term should be common in both the brackets, which yes, it is there. 2x square is a common term in both the brackets. So this is my x, that is the common term. A is 5 and b will be minus 3. So just rewrite this expression as 2x square plus 5 into 2x square plus minus 3. So that now this is the common term and this is your A and this is your B. Now what is the identity? First term is x square, means the square of the common term. The common term here is 2x square. So what will I write? 2x square whole square. Just follow the pattern. Don't mug up anything. Follow the pattern. That is important. So x square is actually 2x square whole square. Then there is a plus sign. You also put a plus sign. In the bracket there is a plus b. So I will write 5 plus minus 3 into x. X nahi likhna hai. What you have to write? The common term. And what is the common term here? 2x square. Okay? Plus a into b, that is 5 into minus 3. So now when I open the bracket, I will get 4x to the power 4 plus, now what is 5 minus 3? That will give you 2. 2 into 2 will give you 4. So 4x square plus 3 into minus, 5 into minus 3 will be minus 15. So the answer is 4x to the power 4 plus 4x square minus 15. So I hope it's clear how to apply these identities to write the expanded form. If you look at question number 1 of your NCERT book, first question, use suitable identities to find the following products: x plus 4 into x plus 10. In this, in both the brackets, one term is common. So we can use the identity x plus a into x plus b. I am leaving it for you to do it on your own. Second part, x plus 8 into x minus 10. Again we can use the identity x plus a into x plus b. Just the second bracket you will write it as x plus, in brackets you write minus 10. So your a will be 8, b will be minus 10 and the common term is x in both the brackets. In the third bracket we have 3x plus 4 and 3x minus 5. So the common term here is 3x and a is 4 and b will be minus 5. Fourth part, y square plus 3 by 2 and y square minus 3 by 2. Now here don't get confused. Here in both the brackets both the terms are same and the only difference is of plus and minus signs. So we can use the identity here a plus b into a minus b. So recognizing the correct identity is very, very important. So you will get a square minus b square. In the last part again, both the terms are same in this 3 and 2x, but there is a sign change, that is plus and minus. So again we can use the identity a plus b into a minus b is equal to a square minus b square. Okay, now we will look at the second question, which is evaluate the following products without multiplying directly. First part is 103 into 107. Now you have to write it in a simple form. 103 can be written as 100 plus 3 and 107 can be written as 100 plus 7. We just want to write it to the nearest tens, hundreds, thousand, which makes the calculations easier. Now if you look at both the brackets, one term is common, the other term is not common. So which identity do you think we can apply here? X plus a into x plus b, because one term is common in both and the identity is x square plus a plus b into x plus a into b. So now here in place of x, what do you have in this question? 100. In place of a you have 3, in place of b you have 7. So can we write the expanded form of this, which gives us 100 plus 3 into 100 plus 7 is equal to x square, means 100 square, plus a plus b, that is 3 plus 7 into x, but in place of x we have 100, plus a into b, that is 3 into 7. That makes it 1, 2, 3, 4, 10,000, plus 3 plus 7 will be 10. 10 into 100 will give you 1000, plus 3 into 7 is 21. So if I add 10,000, so 1 plus 1000 plus 20. So 101, this is 1000, sorry, this will be 11021. This will be the product of 103 into 107. Similarly, by using the identity, how can you write 95 into 96? Now 95 and 96 ko, if you write 90 plus 5 and 90 plus 6, calculations will become slightly difficult. So it's better you write it in the form of hundreds. 95 can be written as 100 minus 5. 96 can be written as 100 minus 4. Again I use the identity x plus a into x plus b because one term is common in both the brackets. So I can rewrite it as 100 plus minus 5 and 100 plus minus 4. So this is taking the place of x and x, and this is your a and this is your b. Again using the identity x plus a into x plus b, we can complete this. And the third part here is of 104 into 96. Now if you look at 104 and 96, 104 in the form of hundreds can be written as 100 plus 4, whereas 96 can be written as 100 minus 4. Automatically you can see both the terms are same in both the brackets, the only difference is of plus and minus sign. So what will you do? You will use the identity a square minus b square, which will be 100 square minus 4 square. That means 10,000 minus 16, which will give you 9984 as the answer. Alright.